what I intend to do here is give a quick overview of a method of software project estimation and requirements elicitation that I use in my company. It is derived from industry best practices and adapted in ways that I think matter for research enterprises. And then I will also go into some discussion about how I take that information, put it into proposals in a way that I think makes proposals very, very strong. So with that, we will start. Many of you don't know me, so this is just a slide about me. Some of it is things Marian already said. So I'm going to skip it because you just heard all of the things on this slide anyway. So here's my thesis. The research software, as I think all the people here and associated with this group would agree, is often unsupported in research grants and in research projects and the whole science ecosystem in geology and planetary science and astronomy and biology and everywhere. I think the reason that this is because, first of all, the people applying for that funding don't know how to go about asking for the proper amount of support for the software development that they need to do. And then secondarily, the people judging the merits of those research proposals also don't have a basis for knowing whether an amount of support that is requested is appropriate. These are things that software engineers, people in industry who do this all the time, become familiar with, but it's not part of the scientific training. So I'm trying to clear that gap as quickly as possible for as many people as possible, with the hope that, first of all, we will all get more money to do better development of research software, and secondarily, that the research software that we produce, because it is properly supported, will be higher quality. So the big things, the big place this manifests in a proposal, for those of you who have experience writing proposals, is in what would be called the background section or the justification section. It is in what would be called the work plan section of a proposal, as opposed to the background and justification sections. In my experience, most proposals by people who don't know how to do requirements elicitation end up being dominated by the background and justification at the expense of the work plan. And I've been on proposals, and I've long ago written proposals in which, in a 15-page proposal, the work plan is maybe 2 pages, even though it's a third and sometimes more of the actual merit criteria of the proposal. So the idea is to give you enough knowledge to actually build out that work plan and therefore increase your merit rating along that axis. So the whole idea for having a work plan is to have a plan and then describe it. It's pithy, but it's true. And I think often the reason we don't describe the plan is because we really don't understand it. We know the justification for the science, but not how to describe all the steps about how we're going about it. So here are the steps to making a plan. First of all, you need to scope your level of effort. You need to figure out the requirements. You need to do an estimate, which is how much time or resources, sort of broadly writ, it would take to achieve the scope that you've outlined. And then you need to create some sort of schedule, which is basically how do you distribute those resources or work effort over time in a way that it fits within the amount of time that you have available to do your research. So as a quick preface, I'll note that in my formulation, I'm going to play around with some terms that are standard in systems engineering and software project management. The reason for that is that in research, we often don't have a job such as project manager who is distinct from a job such as systems engineer or software developer as distinct from those management positions. The types of projects I'm talking about are small. Often you might be filling all the roles, or you have you have 5 people and you sort of share those roles. So if you have a background in engineering, don't at me about how I'm confusing those terms. The approach I'm outlining is called task decomposition. The idea is that you take a big project, you break it down into small pieces, you estimate each of those small pieces. This works because small pieces are easier to estimate than big pieces. And also the errors on many small pieces will tend to average out if you do it correctly. That is, some of the pieces you'll overestimate, some of the pieces you'll underestimate, but your slop in your ability to estimate will tend to average out over the project, and hopefully on bulk, you will actually end up with enough resources to do the work you need to do. So steps to project scoping, sort of going to read this, I'm sorry. You have to figure out what you want to do. To do that, you need to get the people who are invested in the project success, and you need them to all agree on what the actual project is. To do this, you can create what's called a vision and scope document, which is like 2 sentences, maybe 5 sentences, something like an elevator pitch, but a clear statement of what it is that you all want to achieve with this project. And everyone needs to agree on it. And it needs to be stated clearly enough that there can be no misinterpretation. And this really forms the foundation of the whole project. And if this is wrong, the whole project will be broken because you will be building the wrong thing, or half of your team will have a different idea about what project success looks like. So even though it's only 2 to 5 sentences, this might be something you take days, weeks to work on, and it can form the basis of your proposal. So vision and scope document, step number 1. Step number 2, something called a concept of operations document in systems engineering parlance. This is a document that describes, from the user's perspective, the critical features of the system that you want to create. So it's important that it's from the user's perspective, because users are not necessarily developers. They're not going to have a technical understanding of how the system works. So you want to drag statements out of possible end users like, I need it to display an image so that I can do this, this, and this thing with it. And then the technical details we're going to save for the later stage. To do this, you'll want to interview users. And that's sort of a big topic that I won't go into too much, but in the special case of scientific research, the users might be you, or they might be your students or colleagues. It's important that you not, most important for this, that you not develop your concept of operations in a vacuum, that you're actually considering all of the people who might touch your software and taking those perspectives into account so that you can have a complete picture of what it is that the project needs to accomplish. Third step, something called a requirement specification document. Rec spec is like the slang term for this. The requirement specification, as stated, specifies the requirements. It is the complete set of conditions that, if achieved, would meet your vision and scope, and by extension, the concept of operations. By definition, anything that is not critical to meeting your vision and scope, not a requirement. And if it's not verifiable, that is, you can't say for sure that the specific requirement has been achieved, not a requirement. So these a verifiable list of conditions that enable you to meet your vision and scope. Importantly, there are a few caveats in here. Importantly, requirements are what the system must do, not what it must be. So you don't want to, again, at this stage, you don't want to impose a technical requirement where you didn't need one. You don't want to say the system will be written in Python, for example, unless it's really important to the correct functioning of the system that the system be written in Python. The completeness of your requirements is fundamental to your ability to estimate, because we're going to estimate based upon the requirements, the specific tasks and things that we need to achieve in order for the project to succeed. So you want to make sure the requirements are complete, bring in the same list of stakeholders, the same list of end users, and make sure that that everything has been covered. So here's a list of common software requirements. I won't read through them all because you can do that. But this is a list that I reference when we're doing an estimation exercise. I see one of my employees online right now, and she can confirm this if you ask her. We reference this list when we do estimation exercises to make sure we've checked all the boxes, because if we miss a requirement, it will translate to a bad estimate and therefore incur extra project risk when the project is actually underway and we don't have enough resources to do all the things that we need to do. So having done all that, I've raced you through like a full semester of systems engineering, project management coursework. We're going to get to the estimation method. Like I said, this is a method called decomposition. The idea is that you break the big project into smaller projects. Each small project or task or subtask, each one of those should be something that you can conceive of doing, or whoever will be doing the work can conceive of doing. It's not important at this point that you know how to do it. We'll take into account later the fact that you might not have a precise solution, but you need to be able to imagine that it's something you could do given enough time, reading, study, whatever. An example of this would be, say your requirement is that you have to get across town. All you need is confidence that you can achieve that objective. And it's not important right now whether you're going to get across town by bus or train or teleportation, just that the objective is achievable. That's how you establish a subtask. There should be about 10 to 20 for projects, research projects of the scale I'm talking about, small single PI research and analysis grants. And again, push off technical solutions as much as possible. Now, that might not be entirely possible at this stage. You might have to make certain technical decisions in order to break something down into specific tasks, but as many technical solutions as you can push off until later, do that, because it will provide you with more flexibility later to deal with issues, especially once your project is underway. Some common categories of missing tasks. These are things you want to make sure you are in your breakdown. Low-level implementation, optimization, documentation, data organization, cleanup. This list of things, many of which are not like software development per se, will tend to dominate the whole project. I think on a typical, a well-achieved software project, maybe actually writing code is like 10% of it, and a whole lot more is taken up with maintenance of the organization, both in the code and the people, and having meetings and documentation. So again, this is a list of commonly forgotten task categories that I suggest you reference, and that we often reference in my company when doing this. So at this point, you have a top level vision and scope, so you know what your project is going to be. You have a concept of operations, which is what will it look like to your users. You have a list of requirements, which is what list of specific verifiable conditions mean that you will have achieved your vision and scope. And then you have a concept of you have a work breakdown structure, which is a list of tasks and subtasks that, if achieved, will accomplish all of your requirements and therefore will achieve your project. For each of those tasks and subtasks, this is the estimation part, and it's a little spooky, but trust me, it works. For each of those tasks and subtasks, you want to go through them and estimate the amount of time on task, what as a consultant I call billable hours, the amount of time on task that it will take to complete each task. And this can be like sort of a gut level estimate. If that's all you have, just I think I could do that in 10 hours. If it's something you've done a lot, you might be more confident about it. You might say, well, I did that last week and it took me 5 hours. So let's say 5 hours. But for every task and subtask, make that initial estimate. A few points about this. If possible, if that person is available, the person who will actually be doing that work, or the people who will be doing that work on each task and subtask, should be the ones making that estimate. The only exception I provide for is like very early career people who really don't have any good track record doing work to spec, and then understanding how their initial feelings about how that work went correlated to how long it took. So if you're more senior people, you should sort of guide them into reasonable estimates, but they should still be involved in the estimation process. So now you have a list of tasks and subtasks and what I call an initial estimate, a number of hours for each one. If you add up those number of hours, that's what I call the lower bound or the best case scenario estimate for your project, which is to say, if the project goes exactly to your expectations, which is by definition what you asserted when you made those estimates. If the project went exactly to your expectations, then that is the amount of time that it would take you, because it's time and billable hours, and because personnel costs dominate, in almost all cases, personnel costs dominate the total project cost for software development efforts. That basically defines your lower limit for project feasibility. So if you have a number of, say you have 100 hours and the average fully loaded with IDC and fringe and all of those things, if the average fully loaded cost per hour of people in your organization is say $250, then the minimum possible amount of money that this project could cost is $25,000. I think that math is right. So if your grant or your manager, if whoever you're asking for money is not going to give you at least that amount of money, then you should probably consider the project possibly not even feasible. I would certainly think long and hard about undertaking it to that point without changing something. So that's the lower level estimate. That's very, very useful. I also advise you never tell that number to anyone because they'll think it's a negotiation point. They'll anchor to that number and try and talk your estimate down to the lowest possible amount, and that's going to defeat the whole point of doing an estimation in the first place. So for each one of those estimates, just cover that column, ignore it, and then go down the tasks and subtasks again, and for each one, assign what I call a confidence interval or a confidence scale factor to each task and subtask based upon primarily your previous experience doing similar work. So the scale factors I suggest are 1.2, 3, and 4. And 1.2 is the scale factor for work that is very, very similar to work you've done before. Like if you're creating a web page, it's just plain text, there's no fancy widgets. This is something you've done before. You have a good basis, both psychologically and if you kept notes, you have a record of how long that task took you, and you have a good basis for making an initial estimate. So assign a scale factor of 1.2 to that. 3 is for things that are in your, and 2, 1.2, 2, 3, and 4. 2 is for things that are similar-ish to things you've done before, but you haven't done exactly that specific thing. 3 are for things that are in your general domain of expertise. You haven't done that exact specific thing. You kind of have an idea about how you go about it though. And then 4 are things that you think you can achieve. They are outside of your previous experience. It might require extra study or acquiring new skills. You're confident you can do it. You're not exactly sure how yet. At the point you hit 5, you won't hit 5. At the point you hit 5, you should probably bring someone else in because that's, I would consider that so far out of your current domain that it shouldn't be in your list of in your work breakdown structure anyway, because almost by definition, you cannot conceive of having achieved it. So now you'll uncover that column of the initial estimates and multiply pairwise the hours estimates by the scale factor. And that will give you a number in a third column. The sum of the pairwise estimates, so if it's 10 hours with a 2 scale factor, you have 20 hours. The sum of those is what I call the estimate. That is the project estimate. It is the, if all the steps prior to it were done correctly, it is the amount of money or the amount of hours, therefore money and resources, that is both reasonable and sufficient to achieve the vision and scope. It's obvious to you all of the different things that have to go right in order for that estimate to correlate correctly back to the vision and scope. But if everything is done correctly, then that is a reasonable and sufficient request for the support of the software development that you want to do. Importantly, I use those terms because at least for many of the proposals I apply to, and I think, which is in NASA, NASA funding, I think this is true for NSF funding, probably other agencies. The criterion on cost reasonableness is reasonable and sufficient, which is to say it's enough, but it's not too much. Now this may, here's a definition of the scale factors. These slides will be shared after. This may seem very spooky. It seems, some people want to call it padding or guesstimation. I know it seems spooky. It's really not any of those things. This is derived very clearly from a long history of software project management approaches. People have arrived at it independently, and it really just does work. You may ask, why 1.2? That's because everything takes longer than you think. That's pretty well established. And if you've been working for a little while, you no doubt recognize that. There are a bunch of other benefits to this, a bunch of other reasons it works. Also, as a supplement to this will be the treatise that I've written, which goes into some more explication about why I don't think this is spooky. And also, more importantly, it works. I use it all the time. Whenever we use it, we do fine. And whenever we don't use it, we do badly. So now let's talk about putting this is an example of the estimation exercise. So you can see all the things I've talked about. Here's the requirements. These are the tests and subtests, the number of hours, the initial estimate, the scale factor for each task and subtask, the final estimate, and then any additional notes that we want to include. This is a very common kind of layout we do for this. This is another example of the same thing. Both of these are from real projects that we actually estimated. So it's not replicated at this point. We just do this in Excel. This is a summary of everything I've just said. So I'll go into some more caveats about this. First of all, I know it's spooky. All estimates are wrong, and you should not expect them to be right. And it's not the purpose of an estimate to be right. By doing a project estimate, you are basically trying to predict the future. You're doing it at a time when you have the least knowledge about the project as a whole. So if it's like the beginning of a 3-year research project, and you're writing your proposal 6 months before, a lot's going to change in 3 years. In some places in the project management literature, they call this the cone of uncertainty. So you start out very uncertain, and then as the project goes on, you can narrow down to the point where 10 minutes before the project ends, you could make a pretty good estimate of how long the project would take. So don't get hung up on accuracy as the goal. And if you have managers who insist on accuracy as the goal, you should try to disabuse them of that. The purpose of an estimate is to be useful. And to my way of thinking, it is useful if it allows you to request and receive, which includes properly justifying the amount of resources necessary to make sure that you can deliver on the things that you have promised to deliver. You should, because things will become more certain over time, you should re-estimate periodically throughout the project, because you will have more information, you'll be able to do a better job. Re-estimation also allows you to know if you're running like way off the rails, especially once resources have been allocated. If you find suddenly that in order to even achieve project success, you're going to need more money than you have left, then something's going to need to change. You either will need to change your ambitions for the project or request more money if that's possible. So the perhaps most useful bit for all of us is how to put this information in the proposal. I started maybe 8 years ago, routinely doing this to help me develop the work plans for proposals. And demonstrably, my proposals got much better, much higher quality, more readable, more convincing. And as a consequence, I enjoyed a higher rate of funding than I had enjoyed in the previous 6 years of attempts. So I think including these artifacts, including all of this groundwork in your proposal, will really help. It's a requirement in my company. One of our requirements is that every proposal, 1/3 of every proposal must be work plan, no less. So we have to fill that amount of space, and we fill it with the information that we develop by going through this exercise. The work breakdown structure is very nice for proposal preparation because it naturally forms sections of a proposal, especially if you have big tasks. Say you have 5 big tasks. Well, there's 5 sections in your proposal. You can go into each one individually, and it's very logical. And then you can tie it to an actual chart that has your work breakdown structure in it, which is very useful for the reviewers to know, okay, they've listed all of the things they need to do to achieve the project. They've accounted for all of them in this chart with hours and people attached to it. It just really tightens everything up and closes the loop. And by having gone through this process, you already have it. It's not something you have to race to finish in the last 12 hours before the proposal is done. Excel is fine for these. There are software tools that will help you do them, but for most scientists who aren't primarily project managers, it's probably overkill. So here's an example of an Excel template. You can reference these in the slides that will be shared. But it's very simple. This is something called a task matrix. So these are the requirements from the requirements elicitation phase, and these are the tasks from the work breakdown structure, from the task decomposition, and you simply highlight as a visual aid, these 3 tasks achieve this requirement in combination. These 2 tasks achieve this requirement. It again tightens everything up, makes sure, helps you convince yourself that you've captured everything, that there's not unaccounted effort, and also helps convince the review panel that you've captured everything, and they're not going to come back with a comment like, well, you didn't think about this thing that you need to actually achieve the project. Another artifact of this type is called a Gantt chart. It's named after a guy named Gantt, not an acronym. These are, everyone's seen their calendars with tasks and a timeline, and then the tasks are assigned specific periods of time. With the process that I've already described, you have all the information, plus a little accounting. You have all of the information that you need to create a Gantt chart. And again, it's something you can do in Excel, and these, in my opinion, are mandatory in research proposals. But they're easy to do once you know what goes into them, and you don't have to guess about what all of these things are. So once again, these are the tasks from, so say task 1, subtask A. The estimate, so this is the initial estimate times the scale factor, goes in here, and then you just distribute that effort over time, over whatever the amount of time you have for your project is. There's some more that can go into it. You can think about how dependencies flow. So certain tasks need to be finished before other tasks. Certain ones need to be taken in parallel. You can add to this You can add to this a column that shows who is assigned each task. An important thing in many proposals is that every person named in the proposal has a clear job to do, and they're not extraneous, and also that every job in the proposal has a person who is responsible for it. So that can be easily incorporated into these Gantt charts. And this is just done in Google Sheets. You can do it in Excel, and then you drop that right in the proposal, and it's a very clear description of how the project will go, how you expect the project to go, and it's really useful. It's the number of, even if this takes a whole page, the number of words it would take to describe this in a way that no one misinterpreted would be well more than the volume of text that it takes up. Here's another Gantt chart. These are all Gantt charts from actual projects that I've proposed. So some final tips and strategies. I already said, I think work plans should take up 30% of the project, of the proposal. And if you go through the scoping and estimation exercise, that should be no problem. All of that work should have already been done for you at this point. Include these big graphical artifacts that explain clearly all of the work that you've done, and make sure that those artifacts tie clearly to things in the text. So you can make it easy for reviewers to say, what is task 1A? Oh, it's over here in the text. There's 3 sentences describing it. There's no question about what they're doing for this. That's related to verifying consistent terminology between the charts and the text itself. Include a Gantt chart and everything. Make sure everyone is assigned a task. And as a final point, you have to assume, this was sort of my first point, it's also my final point. You have to assume that reviewers don't have an understanding of this project scoping and estimation procedure, and it will, if left unexplained, they will perhaps not unreasonably assume that you have completely pulled all of these numbers out of thin air and you have no basis for them. So I suggest when you use this method, include a few paragraphs explaining what you did, how you arrived at the estimate, that there's a real basis for it, that there's a history in project management literature that ties this to something real, and it's not just a guess. And that will alleviate concerns that your numbers are completely made up and you haven't really thought hard about how much time you need to do things. So here's some reading. You can check the supplementary slides for these. These are just very good books on software estimation. I will note almost all literature on software estimation is geared towards an industry context, and there are a number of factors in industry that rarely occur in science. One of which is, for example, incredibly large budgets and huge teams. So if you're working at Microsoft, which I haven't done, but I assume at Microsoft something like a $10 million budget and 100 software engineers working on a project is not unreasonable. That happens in science, but it's rare, and those are special cases at the scale of like major DOE projects. On the scale of an individual researcher or university professor, we're talking perhaps $300,000, $500,000, 3 to 5 people, 3 years, not working full time over those 3 years. So it's a different scale of effort. And for that reason, most of the literature on software estimation just doesn't apply in our case. So to that end, I've written this, I call it a treatise on software project management, specifically for researchers working at the scales that I just described. And most of the contribution that I think I made with that is just stripping out a bunch of the stuff from the software estimation literature that doesn't apply most of the time to people in conditions like ours. And then also using terminology that might be more familiar to people coming from a research science background. There's some additional reading, which you can check out later.